Hi, this is Mr. Mack. I want to talk today a little bit more about solving systems of equations. Now, we'll start out with the word systems. A system, to a mathematician, is two or more equations in two or more variables. And what we ask ourselves is, what are the numbers that we can put in for those variables that will make all of the equations in the system true at the same time? Now, in the last concept video, we talked about the method of, the concept of systems and the geometric interpretation of two variable systems where you have lines or curves, and the places where their graphs intersect will be where the solutions to those systems are. But now, until recently, with the advent of technology and graphing uh, graphing calculators and computer software and so forth like that, the graphing method was not the method of choice for solving these systems. So we have come up with a number of different algebraic ways to solve systems of simultaneous equations. Now, I want to talk today about two basic methods of solving systems. The first method that I'd like to talk about is the method called substitution. Now, I'm going to work with a system of simultaneous linear equations. So let's just go ahead and make one up here. If we have x plus 4y is equal to 10, and let's do, well, let's see, just a minute here. How about 5x minus y is equal to 8. And we'll make this our system. Now, the idea here in substitution is we take one of the equations in the system and we solve for one of the variables in that system. For example, in this case, we would probably take the first equation and solve for x. Now, if we have the equation x plus 4y equals 10, then it's easy to subtract 4y from each side, and we get x equals 10 minus 4y. Now, we call this solve for x because we have x equals and everything else on the other side. Now, what we're going to do is we're going to take the other equation in the system, and in place of x, we're going to substitute 10 minus 4y because that's what this first equation tells us that x is. So we have in the second equation 5x. Now notice, instead of writing x, I wrote parentheses because I'm putting something in where x is, minus y equals 8. Now, that's the second equation, and x, we're told by the first equation, is 10 minus 4y. Now that's the substitution. What is x, or the expression that represents x in the first equation, is substituted in the second equation. And now we have an equation that just has one variable. Well, actually, the variable occurs in two different places, but it's the same variable. So we can solve this equation. We have 50 minus 20y minus y equals 8. So if we subtract 50 from both sides and combine the two y's over here, minus 50, we get negative 21y equals negative 42. And if we divide both sides by negative 21, we get that y is equal to 2. Now, we are not finished. We have just found one of the variable values, but the solution to this system is going to be a set of, it's going to be an ordered pair, in other words, an x number matched with a y number. So now we need to find the value for x that's matched with y. And the easiest way to do that is to take the value that y is 2 and put it back in one of the original equations. So I'm going to take this equation right here and I'm going to put 2 in for y. Now that gives me, and put it down over here, 5x minus 2 equals 8. Add 2 to both sides, 5x equals 10. Divide both sides by 5, we get x equals 2. So it appears that the ordered pair, 2 for x and 2 for y, makes this system true. Now, it's important to check because there's a lot of places where you could make a mistake. And the easiest way to check is to take the pair of numbers you have, 2, 2, and put it in the equation that you did not use to find the second variable. See, I did not use x plus 4y equals 10 to find x, the second variable. So I'm going to take that equation, x, which is 2, plus 4y, 4 times 2, equals what? Well, we're hoping for 10, right? Well, we get 2 plus 8, and that is equal to 10. So the system checks, and we can now report that the solution is the point 2, 2. Now that's the substitution method. Let's just go back over it and take a look again. In the substitution method, you choose an equation. I chose this one. And you solve for one of the variables in that equation. I chose to solve for x, and that's this work right here. Here's that first equation, solve for x. You then rewrite the second equation and substitute in the expression you got for the variable you solved for the variable in the second equation. You then solve that equation because there's only one variable at that point. Then you use the value you get for that variable back in one of the equations. We use this equation with the value for y that we got here and solve for the other value, and then check your answer in the other equation, which in this case was this one. And if it checks, then you can confidently report that the solution to the system is the solution that you get. Now, this is the substitution method. And it's easy to see why it's called the substitution method, because we are substituting one expression for another variable. Now, the second method that we're going to be talking about today is elimination. Now, let's see if we can't. I'm just going to clone this page. Now, I'm going to take all of this stuff away from our system. Oops, no, I want to leave the equation. I don't want this, don't want that, don't want that. Now, so we'll get rid of all of this. And we're going to solve the same system, but now we're going to use the elimination method. Elimination. Did I spell that right? The elimination? Okay, yeah, it just doesn't look right. All right, we're going to use the elimination method to solve the system. Now, in the elimination method, what we do is we take the system and we transform the equations so that either x or y, or whatever variable you have, one of the variable terms have the same number but the opposite sign. Now you can do either one. In this case, it looks like it would be easy to multiply the second equation by 4. If we multiply the second equation through entirely by 4, notice that the y term will become negative 4y. We already have positive 4y in the first equation. So let's do that. X plus 4y equals 10. And the second equation becomes 20x minus 4y equals 32. Now, what we're going to do is we're going to add the two equations together. Now, the book will let you subtract if you want, but I recommend that you stay away from subtracting. The easiest way is to just multiply, and if you need to, multiply by a negative so that you have the same numbers as the coefficients of one of the variable, but opposite signs. That way, you won't have as much of a chance of making a mistake. Now, we add x plus 20x is 21x. Positive 4y plus negative 4y is 0, and 10 plus 32 is 42. Now, if we divide both sides now by 21, before we do divide by 21, notice the equation I get, 21x equals 42, we have eliminated one of the variables, and we have an equation in one variable that we do know how to solve. So solve it, divide both sides by 21, we get x equals 2. Now go back to one of the equations. How about the first one? And the rest of it looks pretty much the same as what we did before. We have 2 plus 4y equals 10. Subtract 2 from each side. We get 4y equals 8. Divide both sides by 4. Y equals 2. And then check in the other equation. 5 times 2 is 10, minus 2 is 8. That checks. So again, the solution to the system is 2, 2. And that's the elimination method. Now sometimes you are going to have to multiply both equations by something to get the coefficients of either x or y to match up. But that is basically the elimination method. Now, one more thing to talk about, because remember, with linear systems, we talked about a little earlier that sometimes linear systems don't have any solutions, or sometimes they have infinitely many solutions. Now, how does that look algebraically, you ask? Well, let's take a look at a system that has no solution. And we'll just make it very easy here. How about the system 2x plus y equals 7 and negative 4x minus 2y equals 19. Now, this system will not have a solution. Let's start by using the substitution method here. In the first equation, this one becomes y equals negative 2x plus 7. So then we take the second equation, negative 4x minus 2y equals 19. And for y, we put in negative 2x plus 7. And we solve the equation. Negative 4x plus 4x minus 14 equals 19. And when we combine our x terms, we get negative 14 equals 19. Now, I told you when we started that this particular system would have no solution. And this is the tip-off. This is where you will see that there is no solution to the system, because this equation, when we got rid of x, or when we got rid of y, x disappeared of its own accord. We couldn't help it. And we get an equation that's false. Now, here's the idea. Whatever you can put in for x or y that will make negative 14 equal to 19 is the solution to this system. Well, this is silly because negative 14 can never be equal to 19, and therefore there is no value you can put in for x that will make negative 14 equal to 19. There will be no solution. So whenever you're using substitution or elimination and you get an equation where the variables disappear, if the equation is true, you'll have infinitely many solutions. And if the equation is false, like negative 14 equals 19, you'll have no solutions. So that's what it looks algebraically, what it looks like algebraically when you are solving systems algebraically and you have no solution or infinitely many solutions. And we are done.